Abi Nizar, Mremoy, Shu Young, and who else? Shu Young, Nana. They are one of the 15 teams for the first responder, which was sponsored by the NIST.
Great.
Oh, congratulations.
Congratulations to them. 11 industry and for academia, which we are one of the 4.
Great. So I think the recording has been started, and we can go ahead and start. So good afternoon, everybody. Welcome to today's NCCAV seminar. So NCCAV seminars commonly on the last Friday of the month, but this time because of the Thanksgiving, we push it a little bit earlier. So the past seminars are already available and posted to the websites, and feel free to check it out if you have missed any of the past seminars. We would like to thank NCDOT for sponsoring this effort, as well as the gold sponsors of the center, Downtown Greensboro, Verizon, and RTI. With that, it is our pleasure to have Dr. Prithvi Manjunatha to be the speaker for today's seminar with the topic on implementing solutions for transportation research and evaluating emerging technology, which is a stand for IS-READ. Dr. Manjuta is the IS-READ Testbed Manager and Research Assistant Professor in the Department of Civil and Coastal Engineering. His experience has been in connected and autonomous vehicles, CAV infrastructure, human factors and driver behavior, traffic simulation, intelligent transportation systems, traffic operation and data management. He is coordinating with the City of Gainesville and Florida Department of Transportation in the planning and implementation of IS-READ projects. He works with the project PIs and industry partners to coordinate software, hardware, and application efforts and ensure consistency and interoperability of the various components of the testbed. With that, I would like to pass it to Dr. Manjuta, and thank you so much.
All right, thank you so much, Ali. Let me share my screen. So, okay, can you guys see my screen?
We do, yes.
All right, great. Thank you so much
you
for
can
that.
make it on the fullest.
I have 2 screens. For some reason, the second screen always picks up the full screen. If it's okay, are the letters legible? I can try to make it a little bit.
I think you can switch the screen, isn't it?
Okay. Is it okay is this view okay enough?
For this slide is okay.
Yeah.
Let's move on then.
Okay, yeah, let me know if you are not able to see anything. Thanks so much for that introduction. So one of the changes that you can clearly see is we have rebranded ourselves as a living lab as opposed to test bed. So we were thinking how we describe ourselves to people, and we always found that the definition of test bed was somewhat limiting in terms of what we do. So we decided to rebrand ourselves as a living lab. So, and the testbed being one of the components of living lab. I would like to keep the presentation today more like a story of IS-READ. We are a very young program. We just started out in 2017, and we are still in the nascent growing stages of a living lab. So I know that there typically I've been told that you do like 40-45 minutes of presentation followed by Q&A session. I am more than happy to take questions if you have questions as I speak. What I'll try to do is I'll try to tell this story of IS-READ from the past to present and the future, while highlighting some of the key projects that we have done or doing in the last three years or so. Okay. With that, so I'll try to. So IS-READ is basically an acronym, long acronym for Implementing Solutions from Transportation Research. and evaluating emerging technologies. So obviously the latest emerging technology that everybody is working on is the connected and autonomous vehicle world and the infrastructure related to that. We are equal partners with Florida Department of Transportation and City of Gainesville on this initiative. So we do have a stakeholders meeting, and we are planning to make it more, organized and structured as we move forward with both the city and the DOT. As I said, we see testbed as one of the components of our living lab. So we see ourselves doing three main things. One is of course the testbed. We evaluate different sensors and equipments, and we work with the industry to do that. Other than that, we generate a lot of data, which is of very high quality, and we are working. We have a complete team from the computer science department working on the data analytics and the big data side of things. And we also develop innovative research products of our own. So we believe that there is enough there to qualify for a number of IPs. So the third component being the research product component. So for each of the projects, when I talk about these projects, you can take a look at which component of iStreet Living Lab applies. As I just told you, we are a part of Florida Connected Vehicle Initiative. Florida State has been very CV and AV friendly, both from the legislation and from the DOT. And all the yellow stars that you can see are all where we are doing different projects with different Florida DOT districts. So when I say, iStreet, it's not geographically just limited to Gainesville. We are everywhere. So within Gainesville, this is our live. If you go to our website, you can see this live map. We try to keep this updated every few months or so in terms of if there is a new sensor being equipped, new RSU coming in, new sort of equipment, radar, lidar, anything. We try to geotag it to a specific intersection or wherever we are using it. And as you can see, there are a number of projects going on. So I told you today is going to be more of a story of iStreet. So we'll use this as a roadmap for our presentation today. So this is how the presentation is going to flow. So we started out in 2017. So I'll start in 2017, and I'll go through the key projects, and then we'll end up with present day and future. Back in 2017, FDOT was figuring out, this CV, AV, and CAV, terms were being thrown, and they wanted us to do a simple, literature study as to see where, state of the art was at that time, and see, how to bring Florida to the forefront of this. So when the conversation picked up in 2016, late 2016, early 2017. So the City of Gainesville and UF and the Florida Department of Transportation sat together and gave birth to the iStreet program. So one of the first few funded projects under the iStreet program was co-funded by both Florida DOT and the National Science Foundation. And as a product of that, we came up with this optimization software called Real-Time Intersection Optimizer. As you can see, there are three main black boxes here. One is a sensor fusion system. What it does is it takes input from different sensors, be it video, radar, lidar, DSRC signals, and it fuses all of them together to come up with a reliable vehicle arrival stream. Right, and once we get the reliable vehicle arrival stream, we have developed a system of optimization algorithms to come up with two different things. So there are two different kinds of optimization happening at the same time. So one is the optimization of the signal plan. So we will send out signal plans to the signal controller, and then is the optimization of trajectories. So we will send the recommended trajectories back to the connected vehicles. So and once the signal plans are sent to the signal controller interface, they are implemented in the signal controller. So this is the set of different pieces of code put together into one software. We call it real-time intersection optimizer. Since this was the earlier versions of this software was developed in 2017, we are still developing it and adding more features as we go. For example, the initial version of the software didn't have the LiDAR capability, and initial version of the software didn't have the pedestrians and other road users in the mix. So we started out from this base and we built on it. And this has been tested several times now in the traffic engineering research facilities of Florida DOT. So this is our AV. This is our custom AV from our mechanical engineering department. We call it the Navigator. So this is our custom AV. We use this. We also came up with our own custom OBUs. We built this radio kit ourselves. And then, we took it out to the field and we did the testing at the DOT facilities. So this is how, a typical output of recommended trajectories looks like. With every iteration of the software, we are thinking about, what best way to design these trajectories, to have a smooth movement, and not having to do the optimization routine n number of times. We are always trying to improvise on how this trajectory planning looks like. So the next plan is to implement it on the actual road here in front of our football stadium, the Swamp. So once implemented, it should look something like this. So the solid line actually is the tracking of the actual vehicle, which comes from the actual sensor fusion of radar and video and other sensors, whatever is available. And based on that, like the bubbles that you see, let me see for the, so the bubbles that you see is the recommended trajectory for every second, right? 3 seconds from that point, it's supposed to be here, for example. So this is how our real-time intersection optimizer works. This is a co-funded project by FDOT and NSF, and we got funded again a couple of years ago to add pedestrians and lidars into the mix. So this is a living, breathing project we intend to keep going. So once projects like that were born, FDOT also funded the I-75 frame project, where FDOT installed a number of roadside units on the selected sections of I-75, as well as the arterials that connected to I-75. Following that, FDOT funded multiple projects. One is the Gainesville SPAT Trapezium project, and the other one is the Gainesville Pedestrian Bicyclist Pilot. So the Gainesville Pedestrian Bicyclist Pilot is basically a number of CV applications related to pedestrians and bicyclists. So it was funded a couple of years ago. Right now, it's still on hold because of right of way and other logistical issues. So it is supposed to go live pretty soon this year, this project. So we will be evaluating before and after. We have already done before studies for this project, and we will be conducting after studies once the deployments go through later this year. The other project which is finished, which is deployed, which is installed, is the Gainesville SPAT Trapezium project. So the picture that you're seeing on your screen right now is the University of Florida campus. There are 4 major arterials that surround the campus, and there are 27 traffic signals on these 4 major arterials. And on all 427 arterials, roadside units were deployed from the Siemens folks. And there were about 60 odd onboard units were deployed on the University of Florida fleet vehicles, the Gainesville RTS buses, on the fire system buses, on the City of Gainesville staff cars. So we had about 60 plus OBU users driving around this network of this 27 roadside units. So we were able to do a before-after study for this, and we not only did the traffic and safety study, we also did interview and focus groups of the OBU users. And I have some interesting findings from this study. So we developed this data pipeline to automatically get not only the roadside unit data and the logs from the roadside units, but also use ATS-PM data and the loop detector data. So all of this would be pushed into our AWS cloud, and we store it and we process it, and we have developed an algorithm to basically convert loop detector data into turning moment data, right? Like once we manually edit each signal as intersection and run this algorithm, it automatically generates turning moment counts from the loop detector data and any other sensor data that is stored on our cloud, right? So what we do is we have since we work with the Mectrans folks who are associated with UF, who housekeep the highway capacity software. We also have access to the backend of the highway capacity software. So what we have done is we have also created a system where we can automatically convert loop detector data into turning moment data, and then turning moment data is automatically input into our highway capacity files for each of these intersections. And whenever we want, every month or every week, we can monitor the level of service of all of these intersections, so that instead of just doing one before and one after period, we have like n number of after periods, and we can do a continual evaluation, right? So we developed this tool, and we use this tool for this project to monitor the health of this trapezium network over a period of time. I also have some interesting results to show from this study. Unfortunately, the before and after period coincided exactly with the COVID shutdowns. So what you see on your screen is not just the before and after period for the SPAT trapezium project, it is also the before and after COVID period. So you can see, as soon as the COVID lockdowns happened, there was, a drop in the, intersection delays, because obviously the traffic volumes went down. And as the lockdown was lifted and slowly things were coming back into normal, you can see, like, the delay also coming back to almost normal. So unfortunately, we couldn't exactly say, because of the effect of COVID, we couldn't exactly, separate out the effects of COVID from this effect of SPAT trapezium project. But now that we have this tool, we can just, with the click of a few buttons, we can continue to, keep monitoring this network for, how many ever months we want at a relatively low cost, and keep seeing the effects of, such a CV deployment, over a period of time. We also, as I told you, we also interviewed the onboard unit users. Some of the things we found out from the interviews was that, the interface, the OBU interface itself was very primitive, but the users still found the interface to be helpful, especially when it comes to warnings from pedestrians and bicyclists. UF campus has a lot of bicyclists, pedestrians, as well as, those scooter users. So and the driver said, the warnings were actually helpful for them to be more, cognizant of, other road users other than other cars on the road. And they also have suggestions for us, saying that, instead of just like a visual based system, if there was also an auditory input, it would be useful. And also, if the OBU was integrated with an existing navigation system, they don't have to use two different things to, for their GPS and the warnings. Those were some of the OBU experiences. Overall, it was positive, but there was definitely, room for improvement, as indicated in our focus groups. I'm going to take a small break here. Now that I've discussed these couple of projects, I want to see if there is any questions now, or if you guys want to keep the questions till the end.
So one quick question is, were there any attempts to infiltrate your OBUs or any of your other infrastructure?
So thankfully, we haven't had any of those cases. And also Florida Department of Transportation updated all of their RSUs and OBUs with a security credential management system, I believe back in in late 2020. So halfway through the implementation, they updated all the OBUs and RSUs with their SEMS system. Although it was inconvenient for us because once the security certificates got updated, some of them were not working. We had to have the Siemens folks over and the SEMS folks over to, check and make sure that every RSU and OBU was online and working well. But as far as the intrusion is concerned, we didn't have any such cases.
You mentioned this has been used for real-time monitoring. Is that right? Or I missed?
Yeah, and when I say real-time monitoring, I mean like periodic monitoring. Like, if you want to run it over a week, run it over a month, we can do that. Yes.
What about the delay in the system? When the system gets congested, do you see any kind of real delay? Communication.
Yeah, so the delay in terms of getting the logs from the RSU to our cloud.
Yeah.
Okay. I would not be the best person to talk on that, although till now we haven't had any issues so far. The only issues I heard from the computer science folks who actually run and manage the AWS system. The only issues they have had was, if an intersection went offline, we just had to, talk to the city of Gainesville because they do all the maintenance of the signals within the city boundaries. So that was the only issues I've heard from those folks. But I haven't heard any, bandwidth related issues or delay related issues so far from them.
Thank you.
Yeah. Okay. Great. Interesting questions, very relevant questions. Okay. All right. If there are no more questions, I'll continue the presentation. So coming to, let's say, 2019 to 2020. So we also have an autonomous shuttle in Gainesville, which has been running from the last year and a half or so. It was supposed to start running like much earlier than that. There are multiple issues, NHTSA waivers get slowed down. And, if you remember, there was this incident in Ohio, which delayed all the autonomous shuttles with the Easy Mile folks. But anyway, the good news is, now we have a autonomous shuttle running in Gainesville. Along with the Gainesville one, we are also collaborating with Beep. Beep is one of the most well-known autonomous shuttle operating company in US. They have, I think, more than 20-25 deployments all over the US now. Back in 2019, I believe, when we started collaborating with them, they were only running like maybe 3 or 4 cities, but now they're everywhere, I think, even including Yellowstone National Park. So we did 2 different studies in Gainesville and Lake Nona. So in Gainesville, we did the before-after perception survey. And in Lake Nona, we put cameras out in the field to observe how different road users, drivers, bicyclists, pedestrians interact with the shuttle. So I have a, small synopsis of the findings we found from both the studies, and they actually go hand in hand with each other. So study 1 for the Gainesville, this is the route in Gainesville. Right now it runs from downtown to UF, edge of the UF campus. One of the interoperability things I mentioned was, this shuttle, when it comes to come closest to close to UF, it intersects with the previous SPAT trapezium project I mentioned. So when it's going through one of those RSU enabled intersections, there is an OBO inside the shuttle. It is able to easily talk to the RSU that is on that, and it gets the signal and it makes the turn automatically. So typically, if you look at some of the other shuttle deployments, when there's an intersection, they have to manually, the service operator usually manually operates the shuttle when there's an intersection. But in our case, in Gainesville, it's completely, CAV enabled. Having iStreet as a program is useful in this sense because there are like 2 different companies that are operating, and somebody had to bring them together and make this work. So iStreet, there are small things like small changes like this which can add big value. Is where iStreet has its role. Yeah. I'm pretty sure, if you are in the world of connected and autonomous vehicles, everybody knows that, there are basically three major shuttles in US. One is the Easy Mile shuttle, the other one is the Navya, and the third one is the Ollie. Right now, I believe Easy Mile is number one, followed by Navya, and Ollie is catching up with them soon in terms of the number of deployments over US. And most of these shuttle, although they say that they can go up to 25 miles per hour, most of them actually operate anywhere between 10 to 15 miles per hour. This is because the more element there are on a road network, the slower the shuttle is to react. And I talked to the shuttle operators and the Easy Mile folks and the Navya folks. The common message that I'm getting from all these guys is that it's the limitation is because of the capability of the sensor suite. If they have a better sensor suite, they can actually operate at 25 miles per hour, but that the cost doesn't exactly work out right now. So the short answer is, although they say it goes at 25 miles per hour, if you take a look at any of the deployment in the US, it's typically 10 to 15 miles per hour. That's going to be an interesting thing as I talk about this study. In our survey, we basically concentrated on three different categories. One, the travel behavior and technology use of the participants and their demographics. And as far as the shuttle is concerned, most studies in the literature, we saw that they only care about the shuttle riders themselves, and they don't really survey in terms of how a driver or a pedestrian would feel if they have to interact with a shuttle. So those two components were added in our survey, when compared to the literature. So here are some interesting results. In terms of survey demographics, our after survey had to be done in the post-COVID era. So most of our after survey was online, and we did leave some QR codes on the shuttle itself and at the shuttle stop. So what happened was we got way more women responding in our after survey, because the literature shows that women tend to respond more if the survey is online, and also because the college students were not as much in Gainesville during post pandemic era. We had under 25 demographic go down in our survey. So we ask questions like how comfortable they are, either riding in the shuttle or riding around or interacting with the shuttle as drivers and pedestrians. As you can see, riding, they were tentative in the before survey, but once they have taken the ride, or once they have at least seen the shuttle themselves, their confidence goes up dramatically. They strongly agree that they're very comfortable taking a ride in the shuttle. The same thing with pedestrians and bicyclists. In the before survey, they were saying, I don't know when the shuttle will stop. I don't have, I may not have confidence that the shuttle will stop, whether I'm crossing the shuttle in front of it, or I'm using a bicycle lane to, go along the shuttle, something like that. There were a lot of, apprehensions from bicyclists and pedestrians. But once they started interacting in the post-exposure survey, their confidence went up again, although not as much as the riders. One category where the feelings became negative was driving. I will tie this to the speed of the shuttle later, because most of the drivers, they get frustrated when they're stuck behind a slow shuttle, and both the shuttle in Lake Nona as well as in Gainesville, they operate on a single lane road. And also we specifically ask the drivers, as a driver, I try to avoid following the shuttle. How much you agree with this statement? The feelings were very mixed in the pre-exposure survey, and in the post-exposure survey, everybody strongly agreed that basically they would avoid following the shuttle if they can. Whereas when it comes to riders, their confidence level went up. We also did a text cloud based on the text responses. The first major category was always about the speed. Why is this shuttle so slow? Why is it clogging the road? So the speed limit on both in Gainesville and in Lake Nona was 25 miles per hour, and the shuttle goes at like anywhere between 10 to 15 miles per hour. Obviously, the drivers are going to get frustrated. In Gainesville, we also have traditionally this east-west divide. The west part of Gainesville is high income, majority white neighborhoods, and the east part of Gainesville is low income and minority majority neighborhoods. And this comments were mostly have to do with traditionally, Gainesville thinks than the shuttle itself, as to why are the authorities spending so much money on the shuttle rather than improving the bus service in my area. Those are the sorts of questions we are getting. But this is a misinformed opinion, because this was not funded by the city of Gainesville, right? This was funded by Florida Department of Transportation. And if Gainesville said no, they very well could have taken this pilot somewhere else. So it was not that, those funds could have been used to improve the local transit service, right? So again, like, this comes into miscommunication between the authorities and certain neighborhoods. I'm talking more about this because we also did a study in parallel to assess the mobility and accessibility in different neighborhoods in Gainesville. We found, even in that focus group and that survey, we found this to be like a common factor. And many of the surveyed, they didn't even know that the Gainesville had a driverless shuttle, even though they were it was the after survey. And because of COVID, we also had some concerns about social distancing and shuttle size and so on. So the next study I'm going to talk about in Lake Nona, what we did was we put cameras in
Ask
three
a
different.
question.
Yeah.
Okay, in these autonomous vehicles, do you still have a driver in the loop in the car, or?
Yes. Right now, most of these shuttle services, they have a service operator, although they don't do anything.
And
Yeah.
then
Yeah.
the result that you mentioned, whether passengers are confident and all that.
Yeah.
Have you published those results, or can you share those information with us?
Yes. Yeah. We have a TRB paper coming up. So I will share the TRB paper with you. So we have the paper coming up for this TRB actually.
We are basically interested on the opinion by the passengers, how
Yes.
they feel about this autonomous vehicle.
Yes. Yeah. I have the TRB paper. So we are making the corrections as we speak for TRB in time. So I'm more than happy to share that with you.
And what about the date? Do you have a data set or that you are it's available for this study?
Yes, we have the original survey. I will get in touch with my co-PIs and to see how, to what extent that data can be shared.
Sure. Okay. Thank you.
Yeah. Okay. All right. So this for the second study on the autonomous shuttle, we went to Lake Nona. Basically, we put up static cameras. We took the permissions from the township and the operators to do this. So we put it in three different locations: a crosswalk, a signalized intersection, and a always stop intersection, to see what sort of behavior we would observe. And we did it over a period of 2 days when we had relatively higher foot traffic from the pedestrians. At the crosswalk, we could obviously see that the shuttle would have longer discharge headways, when we did the with shuttle traffic and we compared it with the without shuttle traffic. And pedestrians, there was a what do you call that, farmers market happening on Saturdays on the south side of this picture that you see here. And when you could see that, if somebody who lives in that township, who's familiar with that shuttle, they were crossing the crosswalk confidently, whereas the visitor who was just coming in for the farmers market, they were tentative around the shuttle. And there were like temporary fences in the orange thing you see here. There was a temporary island created because on farmers market they have way more pedestrians on other days. So they put up these temporary fences that kind of created an island for the benefit of the pedestrians, but that kind of messed up with the detection of the shuttle. So the shuttle was often getting confused. Sometimes it would stop thinking that it's a pedestrian. Sometimes it would just go. And when it came to signalized intersections, because the shuttle was so slow, we saw this multiple times. Even before, like, the shuttle, which is green, would go through the intersection, the vehicle behind it would make an illegal passing maneuver inside the signal box, right? Because of the slowness of the shuttle. And similarly, there is problem with the communication of the intention. At the stop controlled intersection, the shuttle was supposed to make a left turn, right? So this is an always stop control intersection. Everybody gets their right of way. So when the green shuttle wants to make the left turn, the blue through vehicle is supposed to give its right of way when it's the turn of the shuttle. But the shuttle, sometimes it is so slow when it is making that turn that the blue human driven vehicles, they actually think that the shuttle might be waiting for them to cross. So sometimes we see some dangerous maneuvers where some drivers just take off, although the shuttle has already started to make extremely slow but definite maneuver to make a left turn, right? So there are a lot of safety related issues, that can come out of such a deployment. So doing an observation using the cameras was was helpful for us to come up with this nuts and bolts issues. Also, it confirmed from our Gainesville study that we already knew, is that drivers are getting frustrated because of the slowness. And here, like on the video, we captured that because of the frustrated drivers, we are seeing a lot of illegal maneuvers and passing and aggressive maneuvers, which is going to be a safety hazard. Along with this, yeah.
Yeah, one question. So other than this intersection, the other areas, are you using a dedicated lane or no, it is sort of mixed traffic?
It is at the time of the study, it was using mixed traffic, but at the time of study, we also saw that at least for like a small half a mile section of the route, I think they were starting to mark and pave a dedicated lane. So right now, like part of this route might be on a dedicated lane, but at the time of study, it was not on a dedicated lane.
And that dedicated lane also is intersecting with the traffic intersection as well, or no?
So the
Just
dedicated part is actually between this always stop and the signal as intersection. I can actually show you in the map. So this is the intersection and this is the always stop. So I believe like a small section in the middle has been remarked as dedicated right now.
okay, I see. Thank you.
Yeah, yeah. Okay. Yeah, great question. So, along with the video, we also had videos that we took ourselves. We also had access to the shuttle video facing outwards. Of course, they couldn't give the shuttle video facing inwards because that would be a privacy issue. So we got the videos from the shuttle looking outward. So that means we were able to capture the vehicle that is following the shuttle, right? The human-driven vehicle that is following the shuttle. And we also got the trajectory data of the shuttle from the GPS mounted on the shuttle. So when we combine the trajectory data with the video data, we can actually come up with leader follower trajectory, right? And when we have both autonomous leader and human driven follower trajectory, now we have data set to model human driven vehicles, right? So we use the combination of image processing and and trajectory manipulation to come up with this trajectory data. So it's still a work in progress. So we are planning to model human driven vehicles in presence of autonomous vehicle using this data.
Should I say that this is studying the behavior of a driver when he's stalking behind a slow autonomous car?
Yeah, you can say that. Right now, you can
Because
also say that it's basically studying behavior of human-driven vehicle behind a very slow-moving traffic. For all we
right,
can.
that's absolutely right.
Yeah, but
Yeah.
like, as far as the fundamentals are concerned, the basic methodology is concerned. So hopefully, as and when these AVs are able to move at a faster speed, so our methodology should be able to be transferable to do such a study on a wider scale. Like for example, if somebody can get a approval to put a rear view camera on a Tesla and get that data, they should be able to use our methodology to model such a follower leader relationship. Yeah. Okay. So what we learned from both the studies is people are getting used to this technology and they're warming up to the idea and in a positive way. Major concern is the slow speed of the autonomous shuttles right now. And for both of the study, we had to work with multiple stakeholders. With Gainesville, it was Easy Mile, the shuttle company, the Transdev was the shuttle operator, City of Gainesville and RTS was the transit agency responsible for the entire project. Siemens folks was the ones providing the RSU signals, and with Lake Nona, we had to work with the Tavistock Township folks. We had to work with the operating company Beep. So having this relationship is extremely important to not only for for smooth operation of the shuttle itself, but also to do any kind of research and evaluation, and taking these pilots from being just a pilot to where it will lead in the future eventually. And obviously, community engagement is very essential, and communication is a key. Yeah. So I'm going to take another break here before I move on to some of the other projects. Any questions so far?
So maybe as a follow-up to the previous question about the dedicated and mixed traffic sort of things, when you were using the Easy Miles in a sort of mixed traffic setup, how was the difficulty as far as the regulatory aspects of those sort of things? Was it taken care by you or Easy Mile? Who was and how did you manage that sort of situation?
Yeah, that's a fantastic question, actually. So typically the shuttle operator in Gainesville case, it's a Transdev, right? Although EasyMile is the manufacturer, the operator was Transdev. So Transdev is supposed to, whoever is operating the shuttle is supposed to directly communicate with NHTSA to obtain all kinds of regulatory waivers or permissions or permits, whatever. But having the stakeholder alliance was useful because we were in conjunction with City of Gainesville cameras and traffic data, we were able to pull up some traffic data, historic safety data and things like that to Transdev, and Transdev did their own mapping and other things. So when they submitted as a package to NHTSA, it was way more easy to obtain those waivers than the operating company trying to do in isolation, right? That's a good question. So it's usually the operating company which has to file for all these things, but it helps a lot to have a healthy stakeholder network.
Thank you.
Yeah. Okay. All right. All right. So we are coming closer to 2020 and 2021 now. So I'm just going to quickly highlight, a lot of small projects that we did. I might not go in depth on all of these projects considering the time. So we did something called a bike sensor project. So, the city buses, they have a bike rack in them. A lot of the times, because there are so many bikers in Gainesville, people are not able to get onto the bus because the bike racks are full. So what we did was we put sensors in the bike racks, and, and we created an app where people could see not only whether the bus is full, but also whether it has an empty bike rack, so that, they don't wait unnecessarily. We also had a Mobileye, ADAS system on our RTS buses. It's a Mobileye Shield Plus is a warning system for bus drivers, for pedestrians and forward collision and other warning systems. And we did a quick evaluation study, and this is a quick video for the Mobileye system. As you can see, whenever there's a pedestrian crossing, usually, a warning pops up, and the driver gets to know there are multiple, applications for this system. We also did a study on what is the best way to send warning messages to the drivers. So we used, two different apps, Travel Safely and one more app, I forgot the app. And we ran the vehicles through a school zone as well as in a bicyclist zone where we had, bicyclist participants. So what we did was we put eye trackers on the drivers and made them drive through the school zones where the bicyclists were present. So we were able to capture the eye gaze of a driver when they're driving through a school zone. We were able to see for how many seconds they're looking at the app, for how many seconds they're looking at the pedestrian, how many seconds they're looking at the road. And we did it in 3 different modes. One was a stealth mode where we didn't give them the app. The second one was a visual mode, audio visual mode where we put both audio and visual warnings. And the third one was an audio only mode where we didn't give the app as a visual mode. We only sent them messages through an audio message. we found out that the audio messages were extremely helpful to streamline the gaze time, right? We found out that, if we just send visual messages, they will look at the app more than the road, which can, which can be extremely distracting and kind of beat the whole point of having the app in the first place. Not only this, we are doing a number of human factors related, projects. We have multiple driving simulators. I myself have been part of, a couple of driving simulator projects. Not only on road, we also use a lot of driving simulator projects to, track these kinds of things and driver workloads and those kind of things. Dr. Kaber used to work at, NC State. He is now with us here at UF. We added a bunch of human factors things along with him. We do a lot of video and image processing work as well. We have an in-house capability to do near miss detection, right? We have a number of fisheye cameras in different parts of Gainesville, and we are able to identify and classify objects. Whenever there is a near miss, any two objects come close to each other within a certain predefined distance, we are able to tag those and save those trajectories and save those events, which is extremely useful safety indicator, near miss. We are also developing, web-based user interface to track and maintain intersections and analyze intersections. Using these fisheye cameras, we are able to track all the vehicles. For privacy reasons, the cities are not allowed to keep these videos. What we do instead is we stream those videos, we take the trajectories, and we save the trajectories and we get rid of the video. So it is kind of a very good turnaround to work around to get the trajectory data and important safety related events. We have a fantastic data analytics team with Dr. Sanjay Ranka at the computer science department. So we work very close with him and his team. Yeah. So overall, yeah, these are the highlights of all the past projects. Currently, we are doing this exciting project with 4 different universities in Florida. I'm pretty sure you must have heard of the I-4 corridor between Orlando and Tampa. It's one of the most congested corridors and well-used corridors in Florida. I-4 frame project is being funded by Florida DOT, and there are like hundreds of CV deployments, and there are like 14 different applications on this project. Florida Poly, USF, UCF, and UF are doing the evaluation for this project, and we are the primary coordinators for this project. We are working on how to simulate CAVs in VISIM, because VISIM is widely simulated software. We have come up with a framework to simulate CAVs in VISIM, and we are continuing to work on how to efficiently do this and answer a lot of questions related to simulation. We held what is called a mobility challenge event with CoMotion's folks. CoMotion is basically they are a new cities initiative where they do 2 major conferences a year, one in LA, one in Miami, around the topic of mobility and how to use technology to improve mobility. So this year the primary panelist and the guest was Secretary Buttigieg. And the event happened in Miami, although he participated virtually. So one of the key sessions was the CoMotion Mobility Challenge event. We invited everyone from the world. We gave them a data set. We told them, use this data set however you can to come up with some sort of safety or a mobility solution. So 9 teams were submitted the proposals out of the 15 teams which showed initial interest. 3 teams were chosen as finalists and 1 was picked, and that team is right now working with City of Gainesville on a prototype for a safety intersection safety dashboard. Yeah, so we are doing a number of projects. As far as the present and the future of the iStreet is concerned, we are looking at, we recently rebranded ourselves as a living lab because we are growing exponentially every year, and we are redefining who we are and what we do. So we see a bigger role for ourselves within Florida as well as nationwide when it comes to CAV or any emerging technology. And as you know, because of all the uh, uh, rules concerning FCC, DSRC is a old thing now, and CV2X is a big thing. So things are moving forward in that direction. Nationwide, we are looking into that. And FHWA is pushing this cooperative driving automation concept. I'm pretty sure you guys have heard of the Karma initiative from the Lidos folks under FHWA. So we are looking into exploring into that space. What does cooperative driving automation means? What can we do with the deployments we already have? How can we get more value out of what's already there? We are also looking into mobility space and vulnerable road users, like whether it's older adults or veterans or people with disabilities. We are looking into venturing into all these areas. So that is in short like the history, present, and future of iStreet. I am happy to take questions with whatever time we have left.
Thank you so much for a great overview
Yeah.
and exciting projects.
Yeah, I'm so
Thank
sorry. I
you.
had to cram in a lot of projects into like a 1 hour. We typically do like 1 hour for like each of these projects. Yeah.
That was very informative, though. So,
Yeah.
yeah, any question to Dr. Provitic?
Hi, my name is Jelani Owens. I would first like to say that this has been a great presentation. I recently graduated from the University of Florida a couple years ago, and I just think it's amazing just how far just the technology has advanced since I left the school as both like a student and also just a cyclist in general. Because I know, just personally, I use my bike a lot when I was going around Florida. So I have two questions pertaining to the shuttle itself. So I know that you mentioned that the shuttle has a small capacity, I think around 6 students.
Yeah.
And because of that, is there a difference in terms of do the students use their UF card to go into the shuttle like any other bus, or is there a specific thing they have to pay?
Right now it's actually operating on Second Avenue, which happens to be one of the most used corridors by the city buses, right? So it basically overlaps its stop with regular RTS buses.
And then my other question is, so I remember that you mentioned that like the normal city bus, they typically have a bike rack where you can like attach your bike onto. Do these shuttles have that as well, or is that something that
No, the
is not
shuttles do not have bike racks. Although talking about retrofittings, one of the things we learned very quickly is that most of the shuttles are not ADA compliant in their basic model. So we were doing a older adult study as well with the shuttle. So we had to ask the shuttle operators to make retrofittings to make it compatible with ADA compliance. Yeah. Yeah.
Thank you for answering my question. I'm excited to see what the
Yeah.
different projects in the future as well.
Thank you. Go Gators.
Go Gators.
Yeah.
Okay, may I ask a question related to the first part of your talk?
Yes.
You mentioned that you were predicting 3 steps ahead, basically 3 seconds. Three dot that you were mentioning.
Yes.
But do you think that 3 seconds ahead is good enough time?
No. Yeah. I need to clear that out. We are not predicting just 3 seconds ahead. I was just giving an example that the third bubble would be, for example, 3 seconds ahead. I believe right now we are predicting till the stop line, as well as once it leaves the stop line. Does that make sense?
Yeah.
Yeah. So we do have the range, which is limited because of the sensor range. It's anywhere between 250 to 350 feet generally. Sometimes it's beyond that if we have a good sensor. But yeah.
Very good presentation. Thank you.
Mhm.
Hey, my name is Ishtiyaq Ahmed. I'm a postdoc at NC State University. Great presentation. I have one quick question. In slide 12, probably, you talked a little bit about a pilot program for pedestrian bicycles,
Yes.
and so you said you're conducting before and after study to
Yeah.
kind of evaluate the program. What kind of metric did you use or you're planning to use for evaluating the safety impact on
Yeah.
bicycle pedestrians?
Yeah. Good question. Actually, this is something that we are answering currently. Because this project has been delayed so long that actually helps us because when this project was initially commissioned, at that time our near miss capabilities and tracking vehicles capabilities using fisheye cameras was not that great. So thankfully we kind of planned well ahead for this, and whenever we got the budget to install some fisheye cameras, we installed on one of these corridors, and we have like 3-4 cameras on this corridor that you're seeing on the screen. So in addition to regular, traffic and safety metrics like, historic crash data and those things, um, we are also planning to use fisheye cameras to do near miss studies.
Just say, huh?
Like for surrogate safety
It's not.
measure, like are you planning to
It's not
use
just.
Yes. We are planning.
You
Yeah,
have to convert it
like
back, and
conflict?
I don't want that. We want to just upload it there.
I think you may want to put yourself on mute.
Yeah. So are you like conflicts, traffic conflicts using the fisheye cameras?
yes.
All right, great.
Yeah.
Thank you
Yeah.
very much.
Thank you.
So go ahead. There was one question.
Hi, Prithvi. I think great presentation. Yeah, I think I enjoyed learning more about like what are the detailed initiatives through iStreet. I was curious about like what is like the perspective of University of Florida and also Florida DOT about looking into the long term, like specifically like sort of integrating some of these pilots with predicting how would the behavioral changes be? How would the like how many years are we looking into for predicting the plans or transportation? So I mean, I'm just
Yeah.
curious, like what's
Hi,
the
Venkatesh. Nice to see you after a long time.
yeah.
So Dr. Ranka, Sanjay Ranka, that I mentioned from computer science, he is actually coordinator for a lot of data aspects of a lot of these CAV projects, even the projects that iStreet is not evaluating, for example, USF or other Florida University evaluates. Typically, Dr. Ranka from UF is involved in the data component of that project because Florida DOT has this vision within the iStreet program, have this data analytics wing where not only we ingest a lot of data and process it, we also use it to kind of start predicting where those bottlenecks are likely to come, what kind of traffic patterns are predictable, and those kind of things. And I believe his team has already developed a small prototype, I think for Seminole County in Florida, with whatever data we had. So the idea, I believe, is to make it a bigger thing as we go forward. Yeah.
Yeah, I'll look
Yeah.
into those data-driven studies.
Yeah.
Yeah, that's
Yeah.
exciting. Thanks a lot.
Yeah.
So one question from me. There was a mobilized system that you were installing on the buses, and you were trying to see that warning system how can assist the drivers, and
Yeah.
you were testing it almost in near crash sort of scenarios with human subjects. How was that sort of situation was being managed uh, through the sort of justification and those sort of things? While there are specifically some other ways of testing, avoiding without even using human subject there.
Yeah, I mean, like the Mobile, like we didn't do any experiment. We actually installed them on the actual buses that are used by UF. I believe we might have interviewed some of the bus drivers, and I need to check into the project. So unfortunately, among the many projects that I'm co-PI for. I was not the co-PI for this project, so I don't have any first-hand information, but I can definitely get back to you with more details. And Dr. Nitin Agarwal at UF, he was the PI for this project, so I can definitely get back to you either with a project report or with more details for this as to how we
Great.
exactly evaluated this. Yeah.
Thank you.
Yeah. Okay.
So, any other question? Okay, with that, thank you so much again, and for this great presentation. And we'll be in touch hopefully with some follow-up questions if there is any. And have a great weekend.
All right. Thank you so much. Thank you so much, all. It was great presenting to you guys, and have a great Thanksgiving week. And see you all at TRB.
Great, thank you.
Yeah. Bye.
Bye.